For decades, we have imagined a future filled with advanced technologies. We see it in our movies and read about it in our books. These stories often feature powerful laser weapons and intelligent drone swarms. It has all felt like a distant dream, a fantasy confined to the realm of science fiction. But every so often, a breakthrough occurs that pulls that future directly into our present reality. Such a moment has arrived. Researchers in China have unveiled a new drone system that seems to have flown straight out of one of these futuristic tales. It is a technology that challenges our understanding of what is possible right now, today. Imagine a small, nimble drone hovering silently in the sky. It carries no heavy weapons, no bulky power packs, and no complex laser generator. Yet, it possesses the astonishing ability to slice through solid metal from a distance. How does it accomplish this feat? It acts as a flying mirror, a precise relay for a powerful beam of light. A high-energy laser is fired from a station safely on the ground. The drone catches this beam and redirects it with pinpoint accuracy toward a target. This concept fundamentally changes the nature of drone technology, separating the weapon's power source from the delivery vehicle itself. This new system, developed by a team led by scientist Li Xiao, is not just a theoretical concept. It is a working prototype that represents a monumental shift in directed energy applications. The ground station can generate a laser with a power exceeding 30 kilowatts. This is a level of energy that, until now, required massive equipment mounted on large trucks or ships. By offloading the heavy power generation and cooling systems to the ground, the drone is liberated. It becomes a lightweight, agile, and highly precise instrument of power, a simple conduit for an immense force projected from afar. The implications of this breakthrough are profound, stretching far beyond a single technological demonstration. It signals a convergence of several advanced fields: robotics, optics, laser physics, and artificial intelligence. What we are witnessing is the birth of a new class of unmanned systems. These are not just remote-controlled aircraft, they are components of a larger integrated network of energy and information. The drone is no longer just the scout or the weapon. It is a critical node in a system that can project force with unprecedented speed and precision, blurring the line between science fiction and present-day reality. The genius of this Chinese drone system lies in its elegant and sophisticated design. It solves a very difficult problem: how to keep a powerful laser beam focused while it is being reflected by a moving, vibrating object. The drone is equipped with two specialized tubes that look like small telescopes. One tube is designed to capture the incoming laser beam from the ground station. Think of it as a catcher's mitt for light, gathering the energy with extreme efficiency. This initial capture is the crucial first step in the process, ensuring that the maximum amount of power is collected by the drone before it can be redirected. Once the beam is captured, the real magic begins. The light is channeled to the second tube, which is responsible for aiming. This is where incredible precision is required. The second tube contains a series of high-performance mirrors controlled by ultra-fast servo mechanisms. These tiny motors can make thousands of minute adjustments every second. They act as the drone's wrist, allowing it to aim the reflected laser beam with surgical accuracy. This intricate dance of mirrors and motors turns the entire drone into a highly maneuverable optical relay, capable of directing a powerful cutting tool across the battlefield from above. Of course, a drone flying through the air is not a stable platform. It is constantly subject to vibrations from its own motors and buffeted by winds. These tiny movements would normally be enough to scatter a laser beam, making it useless over any significant distance. To overcome this, the engineers developed a very advanced vibration isolation system. This technology acts like a sophisticated shock absorber for the optical components. It creates a bubble of stability around the mirrors, shielding them from the drone's constant motion and ensuring the laser's path remains steady and unbroken. The final piece of this engineering puzzle is the optical stabilization technology. This system works hand in hand with the vibration isolators. It uses sensors to detect any remaining jitter in the laser beam's path. It then makes real-time corrections to the mirrors to counteract these disturbances. The result is a laser beam that remains incredibly stable and tightly focused on the target, even as the drone maneuvers in the air. It is this combination of clever design, the capture tube, the aiming mirrors, and the advanced stabilization systems that transforms a simple drone into a revolutionary laser-wielding platform. The military potential of this laser-reflecting drone technology is vast and transformative. One of the most compelling applications is the concept of a drone swarm. Imagine not just one, but dozens or even hundreds of these lightweight drones working together. They could be coordinated by a single ground-based laser station, or multiple stations. These swarms could move like a flock of birds, navigating complex environments and overcoming obstacles to reach their objectives. Each drone would act as a mobile, retargetable focal point for the powerful ground-based laser, allowing for simultaneous or sequential strikes on multiple targets. This approach offers tactical flexibility that is simply not possible with traditional munitions. A swarm of laser relay drones could be tasked with targeting the most vulnerable points of an enemy's defenses. For example, they could focus beams on the sensitive antennas, optics, or engine exhausts of military vehicles. Because the laser is silent and travels at the speed of light, the attack would be nearly instantaneous, with little to no warning. This capability builds upon China's existing expertise in laser telecommunications and synchronization, skills that were honed during the development of its quantum satellite program back in 2016. The weight savings achieved by removing the laser source from the drone itself is a game changer. A lighter drone can fly for longer periods, travel farther, and exhibit greater agility in the air. This extended endurance and maneuverability mean that the drones can be deployed from safer distances and can persist over a target area for extended missions. Furthermore, the power of the laser is no longer limited by what a drone can carry. Ground stations can be equipped with incredibly powerful lasers, and this power can be upgraded independently of the drone fleet, creating a system that is both scalable and future-proof. However, we must also consider the real-world challenges. China has already deployed other types of laser weapons, like the Li-1 system showcased at its 2025 V-Day parade. But reports from the field, such as Saudi Arabia's experience with the Chinese-made Sky Shield system, show that environmental conditions can be a major problem. Dust, heat, and humidity in desert environments can disrupt optical tracking and weaken the laser beam's power. While this new relay technology is a major leap forward, overcoming these practical, real-world obstacles will be a critical step before it can be considered a truly reliable weapon on the battlefield. The emergence of technologies like laser-reflecting drones forces us to confront some very serious questions about the future of warfare. This is more than just a new type of weapon. It represents a fundamental change in how military force can be projected. The ability to deliver precise high-energy strikes from a distance using swarms of semi-autonomous platforms creates a new and unsettling strategic landscape. It has the potential to make conflicts faster, more lethal, and more difficult to control. These developments have understandably raised significant ethical and regulatory concerns around the globe. One of the primary concerns is the risk of rapid escalation. Weapons that are this fast, precise, and difficult to defend against could lower the threshold for starting a conflict. Leaders might be tempted to use them for preemptive strikes, believing they can achieve a quick and decisive victory with minimal risk. This could lead to a dangerous arms race, as nations rush to develop not only their own laser drone systems, but also countermeasures to defend against them. We could find ourselves in a new kind of Cold War, one defined by the development of autonomous and directed energy weapons. Moreover, the increasing autonomy of these systems raises profound questions about human control. As drone swarms become more sophisticated, they will rely more on artificial intelligence to coordinate their actions and select targets. This leads us down a path toward fully autonomous weapons, systems that can make life or death decisions without direct human intervention. This possibility has been a topic of intense debate for years, and technologies like this bring us one step closer to that reality. We must ask ourselves if we are prepared to delegate such critical decisions to machines, and what the moral consequences of doing so might be. Ultimately, the development of laser relay drones is a stark reminder that our technology is advancing faster than our policies and our ethics. Just as the world came together to create rules governing nuclear and chemical weapons, we may now need a new international framework for directed energy and autonomous systems. We need open discussions about arms control, military ethics, and the rules of engagement for this new era of warfare. This technology holds immense power. It is our collective responsibility as a global community to ensure that it is developed and used wisely, with a deep understanding of its potential to reshape our world.